The next part of the complex numbers involve multiplying a complex number by its conjugate to remove the imaginary part and only have a real number as a result. So we know again what a conjugate is. A complex conjugate means the same thing, only we're trying to eliminate the I as opposed to a square root or whatever, cube root, whatever. So on page 319, you've got a group of problems that say multiply by the complex conjugate and write the result in standard form or something along those lines. Those are problems 39 to 46. So let's do problem number, let's just do 39. So 39 in your book is 9 plus 2i. So the complex conjugate of this is going to be, again, the conjugate would be, if this was 9 plus root 2, we would look for 9 minus root 2. So the complex conjugate here is going to be is going to be 9 minus 2i. So we're going to multiply this by 9 minus 2i. So we have 9 plus 2i. Multiplied by 9 minus 2i. 9 times 9 is 81. The 9 multiplied by 2i and the 9 multiplied by negative 2i will cancel, and then we get a minus 4i squared when we multiply 2i times negative 2i. We know that I squared is equal to negative 1, so we then multiply that by negative 1, so we have 81 minus a negative 1 times 4, which is just 81 plus 4, which is 85. I want to do another one here. Let's do number 43. So in 43, we're only given root negative 20. So there's no I there, but we're going to have to deal with what we have. So let's convert this to standard form. So this is going to equal root 20 times I. Root 20 can be, we can just leave it alone for right now. We can mess around with it later. So the conjugate of this would be negative root 20 times I. So we're going to take, so complex conjugate equals negative root 20i. So when we multiply them together, we get root 20i, and the I is not underneath the radical, times, times negative root 20i. All right, so when we multiply these together, we get negative 20 times I squared, which is negative 1. So this whole thing is just 20. All right, so that's how you do that group of problems. The next group from 47 to 54, they want us to write the quotient in standard form. So we're going to be using this complex conjugate idea to remove the denominator, again, which is something we did using just a square root, the conjugate of a square root. Now we're going to do a complex conjugate. All right, so let's pick a problem. Let's go with, let's pick the first one, number 47. We're given this quotient, 2 over 4 minus 5i. All right, so the conjugate, or the complex conjugate of 4 minus 5i would be 4 plus 5i. So in order to reduce this, we're going to multiply by 4 plus 5i over 4 plus 5i because we can multiply by 1. So that's our first step. And then when we distribute the 2, we get 8 plus 10i. All right, our denominator, 16 is 4 times 4. The 4 times 5i and the 4 times negative 5i cancel. So then we're left with negative 25i squared when you multiply 5i by negative 5i. I squared is again negative 1. So let's do that. So the numerator is fine. Our denominator is 16 minus 25 times negative 1. And then that's 16 plus 25, which is 41. All right, but this is not in standard form, and in fact, it's still a quotient. But we can break this into two pieces, which is 8 over 41 and 10 over 41. So we have 8 over 41 as our A, and 10 over 41 is our B, and then we multiply by I. So that would be the standard form of that. Let's pick another one of those. Let's just do number 51. So we're given 9 minus 4i over I. All right, so our denominator is what we want to remove. The conjugate of I is negative I. So we can do that. I mean, technically here we can just multiply by I. It shouldn't be a big deal, but let's multiply by the complex conjugate. And now we'll distribute the negative I on top in our numerator. So that's negative 9i. And that's going to be plus 4i squared because the negatives will cancel there. And then I get negative I squared on the bottom. And this is kind of why you want the conjugate. Again, it doesn't really matter because we're going to have a negative 1 for I squared anyway. Anyway, here we have negative 9i minus 4 because I squared is negative 1. And we have negative 1, which is just 1. I'll write this in standard form. This is negative 4 minus 9i. Because all we have left in the denominator is a 1. So in standard form, negative 4 minus 9i. And that's how you do those type of problems.